Hello, geometry. Okay, we're going to do a video here for the beginning of our chapter 6, notes on similarity and proportions and ratios. And so this is your chance. I want you to know what you think about this. Follow along in your notes and make sure you take up good notes. If you feel like you totally know what's going on, then just stop the video and try to do it yourself and maybe go back through and check your answers quickly. Or if you need to rewind, definitely do that as many times as you need to make sure you got it down. This is not a very hard section here at the beginning. Okay, first of all, definition of ratio and proportion. Make sure you know what the difference. A lot of people think these words are interchangeable, and they're not. A ratio is a quotient, meaning a division problem of two numbers or two expressions. And the ratio of A to B is written as a fraction, A over B, or with a colon between them, and you know this from 5th grade math, A to B. But do be careful, the order does matter. If it's A to B, make sure A is coming first or on top of the fraction. A proportion is an equation, and here's the difference. A proportion is an equation. It has an equal sign in it of two fractions, two quotients. Or you could say of two ratios. So here we have A over B equals C over D, and we know by now to solve a proportion you cross multiply. You'd say A times D equals B times C. Easy, easy. Now the thing you may not know is there are a name for these products. A and D here, the numbers that go down from left to right, are called the extremes. And B and C, the numbers that go up from left to right, are called the means. We'll talk more about that later, but do make sure you remember which is which. I always think of like, woo, extreme downhill skiing, woohoo! To know the extremes are the one that goes down from left to right. Okay, so to solve these proportion problems, all we're doing is sitting up and then cross multiplying. The first one here is just a ratio problem. There are 15 girls and 12 boys in a class. What is the ratio of boys to girls? Write that down for me. Make sure you wrote boys to girls, not vice versa. So 12 needs to come first to 15. Of course, you can simplify that to 4/5, but the answer 12 over 15 is fine too. And you can as well write it as a ratio this way, 12 to 15. Okay, the second part says what is the ratio of girls to total students? So there are 15 girls. There are 27 total students, so we could write it this way. We could simplify it, divide it by 3, and we have 5 to 9. All the same answer, but the order totally matters. Okay, next problem here. A car travels 115 miles on 5 gallons of gas. How many miles can the car go on 14 gallons of gas? Easy, easy. This is like a 3rd grade problem. Everybody should be able to do this. But do please make sure gallons and gallons are together, miles and miles are together when you set up your proportion. So we can cross multiply. Know that if you want to simplify this first, one side, one fraction, that'll make your cross multiplying a little easier, but I'm not going to bother to do that right now. 5 times x, 5x, that's my means, equal 115 times 14. That's my product of my extremes. And we multiply that out, 14 times 115, divide, of course, by 5. And x is 322 miles. I do expect, this is one of the few times that I'm picky-ticky about making sure you give units in your answer. Okay, the next one. A pitcher gave up 42 runs in 108 innings. What is his ERA, earned run average, which is the number of runs? We're looking for that, x, in 9 innings. Now notice again, we got innings with innings and runs with runs. Welcome to simplify on this one side first. Let's go ahead and do that. If we divided by, let's see, we could divide by 3, and that'd be 14 right over 36. Oh, we could divide by 2 there. We'd get 7 over 18. Okay, so let's change that first fraction. 7 runs to 18 equals x to 9. And then we'll cross multiply. 7 times 9 equals 18x. And so we multiply that, divide by 18, and x comes out to be 3.5 runs, or a ERA of 3.5, which you should know if you know about baseball. 3.5 ERA is not so bad. Depends if you're talking about the Little League or the Major Leagues. Okay, next one. Floor plan of a house is drawn to scale 1/3 of an inch. This is your scale of your house. 1/3 of an inch on the blueprint means 1 foot in the actual house. The master bedroom is 6 inches by 6 1/6 inches on the blueprints. What is the actual size of the room in feet? So think a minute, pause the video if you need to, and see if you can figure that out in your head without doing it in proportions first. Some people can do that really naturally. Okay, to set it up, we need 2 different proportions if we're going to write it out. So if you found it out in your head, let's see if you're right. We're going to have one to solve for the width of the room, and we're going to call 6 the width on the blueprint, and one to find the length of the room, and we're going to call 6 1/6 the length on the blueprint. So the width of the room, 1/3 of an inch to 1 foot is our scale, equals 6 inches to x. We're looking for x feet. Cross multiply 1/3 x equals 6. Flip that fraction, and x would be 18 feet for the width of the room. So for our length of the room, scale again, 1/3 of an inch is to 1 foot, as 6 1/6 inches is to how many feet? Notice again, inches is with inches, feet are with feet. Cross multiply. 1/3 x equals 6 1/6. Now we're going to want to make that fraction improper. 1/3 x equals, that's 37/6. Flip this 3 over 1 to the other side. And that'll be cross cancel to 1. We get 37 over 2, which is 18.5 feet. Whenever you have length and width, you're going to want to write your answer 18 by 18 feet as to what the dimensions of the room are. Excellent job. We're going to pause here and then go to the next page.